Okay, so here's the question: lowest common ancestor of a binary tree. So the question says that we need to find out the lowest common ancestor, like of a binary tree. For example, suppose we are having two nodes as 5 and 1. So lowest common ancestor would be 3. A node can be ancestor of itself as well. And yeah, for 5 and 4, 5 is the lowest common ancestor, and for 6 and 2, 5 is the lowest common ancestor. With lowest common ancestor, it doesn't mean the lesser one, it means the closest one. So yeah. I mean, like for 5 and 4, 3 could have been the lowest common ancestor, but yeah, that was 5. So lowest is like going in the ancestors list, the lowest one, like the initial one. So how do we do this question? As we saw, it's about lowest common ancestor, right? So we need to find something. Yeah, all right. The question talks about finding something. The question talks about uh, you know let's try to figure out like what has to be done. Depth first search, breadth first search, what needs to be done. Yeah. So the question says that find the lowest common ancestor of a binary tree. Now the thing is that to find out the lowest common ancestor of a binary tree, we're given two nodes for which we have to find that. Suppose for example, yeah, suppose for example, we traverse in the left, we traverse in the right. Yep. When we do that, what we observe is that if we encounter them, then yeah, it's fine. I mean, it's about the lowest common ancestor, so it's like we can go till the bottom as well, you know. So I guess depth first search is something we're looking for here, because it's not about a level or something. So yeah, I guess depth first search is something that we're looking for here, because we can be going into the depth of it, you know, finding something in the left, then finding something in the right, or something. So we can easily say that we have to follow depth first search here. But how will we do that? For example, we have it as uh, tree node helper. We'll say let's take all of them. Yeah. But I'll say here, I'll say it's gonna be node. Now what's gonna happen is that if I'll have the base case, if node equals p, or if node equals q, then what I'm gonna do is, if node equals p or node equals q, I'm gonna do is that I'm gonna you know do what? The thing is, I'm confused. Should it be or should it be and? I mean, yeah, my bad. It has to be or. because it's like, if it's going in the left and it's going in the right, so for either of the cases I cannot find two of them together at the same node, so it's stupidity to say it's gonna be and, it's gonna be or. Definitely I'm gonna return that node. Yeah, yep, I'm gonna return that node. It's fine. Understood. So if my node is equals to p or my node is equals to q, I'll be returning that node. So the moment I encounter, like, suppose I have 3, is 3 equals to p or q? No, I'll be like, alright, let's move towards the left. Is 5 equals to p or q? Yeah, it is. I'll return it. Yeah, I'll return that. Now the thing is to talk about how to deal with the returning part, how to deal with the body of it, what to do when we encounter something. Like, suppose we encounter 5, so we'll have to store it somewhere in order to return it, because we're having a tree node type function, tree node I took the example of 7 and 4. Now these two nodes are on the same side of 3. So initially what would have happened was that 3 would have, gone into the left and into the left. It would have encountered everything, blah blah blah. It would have find out the nodes and everything. Yeah, understandable. Now the thing was that for this 5, look at the 5, look at this portion, just look at this portion, just, just forget anything 3108 exists, they don't exist. Just look at this portion. For 5, it would have gone into the left. For 6, it would have gone into the left, null null, it would have returned 6 initially. So now 5's left would have not been null. Yeah, 5's left would have not been null. 5's right, here it was 2. Yeah, 5's right would have been 2. Yep. So initially the thing was that if I was looking for 7 and 4, like, I would have gotten 7, I would have gotten 4, because here in this case, if we look at this tree and then we look at 274 tree, we will find out that 7 and 4, they lie on the opposites. So till now whatever we have written works. I'll show that to you as well. I'll say return helper, yeah, put root into it. Yeah, that's it. This would work. This would absolutely work for, wait a second. What's the issue? Cannot find the symbol helper. Wait, what does it mean? My bad. Yeah. So this would absolutely work for the first example. What's happening? Oh, typo. Helper. Yeah. So yeah, it's working for the first one, and also for this one. It's fine. It's not working for this, because the thing is that I'm having them at the opposites. One is in left, one is in right, so this would work. What if they're in the same line? Yeah, what if they're in the same line? What to do then? Yep, what has to be done then? Now that's the question. And yeah, and also when we're talking about DFS, let's try to understand what approach is this. What type of DFS is this? Herein we have to figure out the lowest common ancestor. So I guess we're considering left and right, but before that we're also considering the node itself, I would say. Yeah, so I guess it's pre-order traversal. It's root left right, it's pre-order traversal, I guess. Yeah, because I'm considering the root, then I'm saying left, then I'm saying right. Yeah, I guess it's a pre-order traversal in my opinion, because first of all I'm checking it for the root, then I'm checking it for its left, and then its right. So I guess it's a pre-order traversal. Now the thing is that what to do with the right one. Now, like, yeah, how to deal with a situation wherein both of them are in the same situation, in the same line. So suppose if you look at this portion, if left portion of 3, we will find this subtree. So we encounter 5, that's good, absolutely fine, that's good. In left, in right, I don't find that. We look at 2, in left, I found that in right. Yeah, so the thing is that it's not the opposites, it's in the same line. Yeah, it's on the one side of the tree, and even if that even if on that one side it's like they're not like against each other, they're like above and below. And here is the thing about the ancestor, that a node can be its own ancestor. So how to deal with this situation? What I can do is I can say that, alright, if for example I'm going into the left first, fine, yeah, that's how pre-order works. I'm going into the left after I'm covering the route. I found the route, I returned it. Now my left. Now understand what's happening. For 3, is it equals to P or Q? No. I say alright, I'll go to the left. I say, is it equal to P or Q? My left. Absolutely it is. Absolutely it is. So now my left would be 5 for 3. Here it's gonna be 3. Here it's gonna be 5. Yeah, because I returned it. Here my left is gonna be 5. It's gonna stop right there. My left is gonna stop right there. Now my right is gonna work. Is my 3 right equals to P or Q? Nope. Is my 1 left equals to P or Q? Nope. Is my 0 dot left or right equals to P or Q? Nope, it's null. It's gonna bubble up null null. It's gonna bubble up 0 for here. So 1's left would be 0. 1's right would be 8. 1 is gonna bubble up to 3. Now 3's right was 1. It wasn't null. Now that's the catch. That's the catch. That why wasn't 3's right null? If I didn't find the answer, why it wasn't null? Because I didn't find the answer. That's the answer to this. I couldn't find the answer on what's on the right hand side because it wasn't. The answer that I was looking for, the node that I was looking for, wasn't on the right hand side of 3. So initially I returned something, but that wasn't the answer. So that wasn't null. So yeah. That means that whatever I found on the left hand side was my answer. Cool. Now that is the answer to this. I don't need to look into more depth. That is the catch. Because yeah, the recursion would stop for the left portion of 3. The recursion would stop at 5. It won't go below. But it doesn't have to go below. That's the catch. If it's gonna stop at 5, it's enough. So I'm gonna say that if node dot left, I mean not left, it's just left. If left is not null, I'm gonna say that the answer is like return right. Yeah. Wait a second. What if I don't find an answer? I mean, I will find an answer eventually. So that is not the case here, I guess. I was thinking like, what if I don't find the answer? What if they both are not null but not the answer? I guess that can't happen. So yeah. If right is not null, so I'll return left. How about this? Oh, it doesn't work. I messed it up, I guess. First of all, let's sort this out for like, what if one of them is the answer that way? Because this is gonna get executed after one of them is the answer. So I'm gonna say if left is not null. Now I'm thinking about answer was on the right hand side of the root. So I'm gonna say if left is not null and right equals P or right equals Q, and if left, if like right is not null but and left equals P or left equals Q. How about that? Alright. Understood. I guess the code works fine, but you know, something is messed up. If left is not null, I can say if it's not equals to, if left is not equals to P, or left is not equals to Q, and if right is not equals to P, or right is not equals to Q, how about that? Oops. What's the issue? I mean, you are equals to the answer or something. Why are you breaking up? Alright, I guess I understand what's happening. The issue is that right is equals to P or Q, so it's returning right. That's the issue. Okay. I understand what's happening. But I'm saying that if left is not equals to P or Q, but it is, so why is it executing even? Why is it executing? I'm saying if left is not equals to P or Q and right is equals to P or Q, so then return right. But my left is equals to P or Q, one of them. So what's the issue? What is the issue? Wait a second, let's frame it like that. If left is not equals to null and left is not equals to P or left is not equals to Q, return right. What just happened? Return left. So if right is not equals to null and right is not equals to P or Q, I guess this is fine. Why? And it's also getting messed up for case 2 as well. What's the issue? Left is not null and left is also not equals to P or Q, so I should return right. Wait, do you want this to happen? How complex can we get? Let's see. My goodness. Uh, I don't understand what's happening. I'm saying if left. Oh my goodness, it's getting messed up. All right, let's understand. Yeah, my right would be not null for 5 and 4. My right would not be null, but it won't be the answer either. Yeah. So I'll have to return some. The question's done. I don't know what's happening with the edge case. I mean the special case or something. The right is not null. Yeah. I'll just write it as I speak. If right is not null. Yeah, I wrote that. If right is not null, and yeah, it's not null. And what else? How much time have I wasted? I would say, yeah, almost 30 minutes. So I'm saying if right is not null, and if right is not null, and left equals to P or Q, then it would be just returning I mean right won't be null, right would be the answer. If right is not null and left is equals to P or Q, if right is not null and right is not equals to P or not equals Q, if right is not null, return left. Because I will find the answer anyway, so then it would be left. If left is not null and left is not equals P or left is not equals to Q, return right. Why? I'm not considering that. I'm saying right is not equals to null, and it's not even the answer. What's happening? Why is it? How come it's returning 5? If left is not null and left is not equals to p, how? Why is it returning left? My right is not null. Yeah, it's not null. It's 1. Uh, it's not equals to p or q. Then you have to return left. What's happening? What's happening? Why is it returning like 5? Why is it returning 5? My right is not null. Absolutely, it's not null. It's 1. And my right is not equals to p. Yeah. Is my right equals to not equals to true? No. Wait, is it something with the operator thing? Like, it's right not equals to p. True. It's not equals to p. Is right equals to, it's not equals to q. False. I guess true, false, true will prevail in OR. It's true. So true and true, it executes. Oops. Oops. Now I understand what's happening. Ah, speak stupidity. That's it. That's it. It will work. It works. It would work 1000%. Yeah, obviously. I was like, right is not equals to p and right is not also not equals to q. Is right equals to p? No. Is right equals to q? No. Yep. I understood. I messed up with the operatives. I was saying something and writing something. What the hell? 1, 2, 3, 4. It's null. 1, 2, 3, 4. P and Q is 4 and 3. Answer has to be 1, I guess. I expected 1. Output is coming out to be 3. Why? How is it possible? How? It's 4 and 3. My one's right would be 3 and my one, suppose we start with left first. Is it the answer? No. 2's left is null. 2's right is 4. Yeah, that is the answer. So 2 would bubble up. That 4 would bubble up. So its left would be nothing. Its right would be something. It's gonna be 4. Yeah. It's gonna be 4. Then I'll be returning the node. I'll be returning 2. Oh, I understood what happened. I understood what happened. Yeah, it makes sense. So the issue is that 2 is bubbling up till 1. That's why it's returning 3. Alright. The point is that 4 has to bubble up. Because node gets equals to P or Q. It gets equals to P or Q. So I return that node. I return 4. Now 2's right becomes 4 and its left becomes null. So yeah, I just do nothing then, I guess, with that 4. This is something that has to take. Alright, now I'll be using some GPT, but because help me understand how to take care for the situation. I understand, but the thing is that I mean that case makes sense. If left is not null and right is not null, I'll return the root, because eventually the thing is that I am gonna find the like there will be no case wherein P and Q won't be present, so they will be present. So yeah, they were found somewhere, but yeah. It's like if left is not null, then if it's true, if left is not null, then return left, else return right. Why? Yes. Wait a second. According to my code, I'm returning the node. So, yeah, I understand why that can have the issue. Yep. So the thing is that if left is not null and right is also not null, I return the node. That is understood. I'll remove this. Now say if left is not null and right is, I mean, my bad, is not null, return node. Yeah, fine. There weren't nulls, so I returned the node. Now I have to do one thing. I'll have to take in consideration of this thing. This thing has to be removed. If they both are not null, I understood. It's like if left is not null, like if left is null, return left. If left is not null, I mean, if left is not null, if that statement is true that it's not null, return left. But it's null, left is null, so I can't return left, I'll return right, which is also null. I understood. But how do I write that thing? I mean, I have done this question before, so let's see the answer. What that answer was. How did I handle that ternary operator? Oh. Oh, okay. So that was like more into if left is null and right is not null, then return right, else return left. Yep. So I guess the question is pretty much done now. It's like if left is not, so basically I'll have to bubble up. The issue was that I was bubbling up the, if left is null, if left is null, yeah, if left is null and also right is also null, I guess. Wait, I said if left is null and right is not null, then return right, else return left. So it's like, what if if left is null and right is also null, so then I'm returning left. I'll just confirm it. Wait a second. If left is null and right is not null, return right. Else, if right is not null and left is, if right is null and left is not null, we return left. Or also if both are null, yeah, makes sense. If left is null and right is not null, return right. Yeah. Else return left. Yeah. Yeah, I mean, for this test case, it's more like, you know, if like left is, if both are null, then I have to return null. That is the basic. That's it. I could have also said, just to be more clear with what I'm thinking, it's true. I can say if, I can just copy paste this and say that if right is null and left is not null, return left if both are null, return null. Missing return statement. I mean, I don't think this thing will ever be taken into consideration, so I just put it because I'm covering everything up. Yeah. You see? I guess that's gonna work. Yeah, because I don't have to worry about this return thing, this return node thing, because I'm covering every particular if condition. If both are null, if one is null, one is not null, if one is null and one is not null, and if both are not null. So yeah. Yep. So that's that for the question. I had to just keep in my mind that if both are null, just bubble up null. That's it. Yep. Because if both are null, then I'll have to bubble up null, because the answer, I mean the recursion reached its bottom. That's why it gave out null. That means there is no answer in that particular side. So bubble up null. It's not needed.